Release the Kraken!
Today we're going to take a look at how to create a physics ball with a camera that you can move around, kind of like Monkey Ball. We're going to go ahead and just do that without Cinemachine because I'm not a fan of it. Go ahead and just create a new project here. We'll do 3D, and we'll go and do, I'll just call this Monkey Ball, just because the setup is very similar to Monkey Ball. And I'll do touch for tutorial. You may notice right off the bat in this video that some things are different. I'm a little bit tinier in the smaller part of the screen, and you can see some of my background partially obscured, but I'm using OBS. Let me know what you think, if you prefer this or my other capture software. Alright, so we have Unity loaded up. So essentially what this is a third-person controller kind of camera setup, and we're going to apply that to a physics-controlled ball. You can really use the same kind of camera setup on anything. The big takeaway is we're not going to be using Cinemachine. So Cinemachine is great for doing a lot of basic stuff, but the problem is when you have a tool and you don't really know how that tool works, like the ins and outs of it, you can kind of get stuck if you want to go further with it. So I want to show you how to set that up without the use of Cinemachine. Anyway, so here we are in our environment. Right off the bat, I'm going to create a 3D object and a plane. Standard, just make a floor of some sort. I'll make this 10 by 10 by 10, that's good enough. And let's make a material, so create, and then let's see, material, let's call that green. And this will be for my ground. Let's go ahead and put that on our ground. And then I'm going to create a 3D object. We'll make a sphere. Set that to 0, 0, 0, and then for the position on the Y, we'll do 0.5. Inside the world here, I'll press F to frame on my sphere so I can see it. You can see it's nice and on the ground. We'll set up the basic rigid body, so add components, and then rigid body, like so. We don't need to do anything special here. That should be good enough. Now for the camera, we're going to create a new one. So right click, we'll go ahead and just do camera. And then we're going to take this camera, and right now it's at the same position as the sphere, which is nice. That's pretty convenient. It's just at 0, 0.5, and 0, which is good. We're going to right click on the camera, and we're going to create an empty parent. And then this empty parent, we're going to call this cam Y. I'm going to right click on cam Y, and we're going to go ahead and create a empty parent, and this is going to be cam X. So cam X. So our camera should be at 0 relative to cam Y. Cam Y should be 0 relative to cam X. And our cam X is going to be centered inside of our sphere, which is at 0.50. Now you might be wondering, why do we need our cam X and cam Y? Well, what we want to do is we want to have the ball rotating using physics. But when it does that, its anchor point, its pivot point, is going to revolve. So if I grab this and I were to rotate it, let's say like this, and then I go back into our movement here, hitting W, you can see that the vectors on here have changed. So the forward of the ball is now pointing at an angle. So if we were to try to drive the ball's position using its forward axis, because its forward axis is changing in some very weird ways, we would get some very odd movement. Instead, we're going to use the forward axis of our cam X to drive the ball's direction. So we can rotate our camera around that x-axis, left and right, and then the ball will orient that way. For our y-axis, for up and down, we're going to keep that separate. And the reason for that is when we modify our x-axis, we're going to be locking out the other two rotation values. So it's just more convenient to set it up on the y for the up and down motion, and we won't use the x and y, or we won't use the x values on our y camera. And then the actual camera here, that is going to be positioned however you like. So I'm going to take my camera, go ahead and zoom out, make sure you're on the camera object, And we're going to move it back some amount and up some amount, wherever you like it to be. And of course you can rotate the camera itself however you would like it to be in world, like so. Okay. Make sure that you keep cam Y and cam X at their default position. Alright, let's go ahead and make a script. So I'm going to right click, create C# script. I'm going to call this sphere. Let that compile. And I'll also bring in a texture. You can download this if you like. I'll leave a link in the description here. This is just a tiling texture that I created in Photoshop. I'm going to apply this to the ball. That way it's easy to tell when it's rotating. So I'm going to just drag that to the ball here. Very good. Let's go ahead and open up our script. So Visual Studio is loaded up. And I'm going to go up to the very top here. And I'm going to make a reference to a couple of the components that we need. So public, and we're going to do a rigid body. We're going to call this sphere. And we're also going to take the our camera X and camera Y objects. So public, and this is going to be a game object. And I'll call this camera X. And the same thing, public, game object, camera Y. For our private section, we're going to do private float. This is going to be move speed. And I'm going to set this to, I don't know, let's try 500. And then we'll do another private float. This is going to be our horizontal input. And then we'll have private float. This is going to be our vertical input. And then we also need a private vector 3. And this is going to be our move direction. We don't need this comment, so I'm going to just nuke that. For the start function, I'm going to call this move sphere. And in here, we're going to do set input values. We'll take our horizontal input, and we'll set that to input dot get axis. And we're going to be calling our horizontal axis here. And we'll multiply that by our move speed, and then our frame rate. So time dot delta time. I'll do the same thing for our vertical input, so I'll just change these. So vertical input, and change this horizontal to vertical, and then the rest is the same. Now just be aware that these are talking to the input values inside of Unity. So if we go to Edit and then Project Settings, and then go to our Input Manager and then the axis values, we are talking to the horizontal and vertical axis inputs. And these are the names, just so you know what those are. So when we put the name in quotes, this is what we're actually talking to. Okay? So it's going to grab, using this name, the axis inputs for us. Now for our move direction, we are going to combine our horizontal and vertical inputs, and we're going to run those based on our camera X's forward axis. So I take camera X dot transform dot forward, and we're going to multiply the forward axis by our vertical input, because our vertical input in this case is actually going to act as our forward vector. We're then going to add to this our right input. So again, we're taking our camera X, transform.right, and this time we're going to multiply by the horizontal input, because our horizontal is going to be our left and right, and again, our vertical is going to be our forward back. And then I'll make a new spot down here. I'll just hit enter a couple times, and this is going to be add force to sphere, and simply we're going to call the sphere rigid body here dot add force, and inside of there we're going to do our move direction. Simple as can be. So whenever we hit a button, that button input is going to be multiplied by our move speed and then adjusted by our frame rate, and that should provide movement for us. If we, let's say we push, W, but we don't push, one of the other buttons, this would be 0 added back to this, so the net result would be 0. But if we push, A or D, and don't push anything on the forward, our left and right will accept a value. If we push both, these two values will be added together. We're going to see that here. Let's come down to our update. Let's go ahead and call our move sphere. Whoops, wrong one. There we go. We'll save that. We'll jump on in. Let's apply our code to our sphere. And then inside of the code here on the sphere, we're going to take the sphere rigid body. And then for our camera X, we're going to take the cam X. And then for our camera Y, we will take the cam Y. Now at the moment our camera won't work, but we should be able to hit play. We can see the ball, and if I were to press left or right, the ball rolls that way. If I press forward or back, the ball rolls that way. And if I press diagonally, it rolls that way. Let's jump back into C# here. And next we're going to create a function for our camera. So under here, I'm going to do a void move camera. Now let's come up to the top here. Underneath our private section for the sphere, we'll make another private section. This is going to be for the cameras. So I'll say private float. This is going to be the mouse X. And then private float mouse Y. Because we're going to use our mouse inputs to drive our camera. We also need to store the Y rotation of our camera as an offset. So we're going to say private float, and this is going to be our cam rotation Y. So we'll store that. Next, we also need the mouse sensitivity values. So private float, this is going to be our turn rate. We'll set that to 500. And don't forget to put the little F on here if it's a float. I forgot to put that one up here for this one. The default is a double. Floats are a little bit shorter, so we're going to just do floats. And then I'll do private float, and this will be my look rate. We'll set that to 500. You can really name these whatever you like. This is basically our sensitivity for the X and our sensitivity for the Y. It doesn't really matter what you call them. But then we also need to store an offset value for our Y-axis. So we're going to say private float, and this is going to be our cam rotation Y. And we'll grab that. Okay, so going off of here, we're going to jump into our camera. We're going to say set input values. And very much like what we did up here, we're going to take our inputs and grab the axes. So mouse X, that's going to be set to input dot get axis, and then this is going to be mouse X. We're going to multiply that by the turn rate, and then multiply that by our frame rate. So time dot delta time. We'll do the same thing for the mouse Y value. So mouse Y, we'll get the axis of mouse Y. And then instead of using the turn rate, we will use our look rate. And then we will multiply by delta time. And let's go ahead and add in our left and right rotation. So this is going to be turn camera left and right. We're going to use our camera X for our left and right rotation. So camera X dot transform dot rotate. And that's going to be a function, so make sure you have your parentheses. Inside of here, we're going to take our up axis. Now you can do this as a new vector 3, and then specify the axis you want to use, like so. and then we would multiply that by our mouse x. Now you can totally do this, of course, but it's actually shorter to just use vector3 dot up. So I'm going to go ahead and just change this to vector3 dot up, which is the exact same thing. Okay, so that'll handle our left and right rotation. Okay. And then we can test this. Let's go ahead and take our move camera here. We'll add it to our update function. So we're going to say move camera. We'll call that function here. Go ahead and save it. We'll jump into Unity. Go ahead and test it. So now I should be able to move my mouse and turn my camera left and right. Now up and down, of course, doesn't work, but if I change the angle of the camera and I move the ball, you can see that it rotates in the direction that our camera is aiming. So if I move it back a little bit and I move the camera this way and I move forward, it's based on the camera's forward axis, which is nice. But of course it doesn't follow the ball, and moving up and down doesn't work yet. So we'll fix that. Come back into the camera. Let's make a new section. This is going to be, we'll say look up and down. For this, we're going to take our camera rotation value, so cam rotation y, and we'll just minus equals our mouse y value, mouse y. As it starts to take on input from our y, we do want to clamp it. We don't want it to go too far out of the range. So we're going to say cam rotation y. We're going to set that equal to math clamp. And inside there, we're going to take our rotation y value. So cam rotation y. And then comma, we'll do minus 90 and then 90. And you can change the value if you need to, but this should allow us to not exceed too high up or down with the camera. And then lastly, we're going to take our camera value and we want to convert it from a quaternion into a Euler value. So we're going to take our actual camera, so camera y, and we're going to take its transform, and then we want to get the local rotation, so local rotation. The reason we're taking local rotation is our cam y is a child of our cam x. So if we try to use the world location, we're going to get a weird value. We want this to move or rotate relative to its parent. So for that, we take the local rotation. So local rotation, we'll set that equal to quaternion dot Euler, and that's a function. Inside of there, we are going to take the camera rotation y, so cam rot y, and we want to then zero out our y value and our z value, like so. You'll see it takes in the x, y, and z values. So this is essentially a vector 3 that is converted from a quaternion into Euler, which is what we see in our output up here. Lastly, we are going to make sure that our camera is attached to our sphere. So I say follow sphere. So we're going to take the camera x. Remember that our camera x is the parent, so we're going to be using that. We'll take the transform and then the position. And we're going to set that equal to the transform of the sphere, which is just the transform value of this overall object. So we can just say transform dot position. We will save that. And then inside here, let it compile, hit play, and we'll adjust the mouse here. Now I can move the mouse up and down, and left and right, and of course I can drive the ball. And if I move, the ball will orient in the direction of my movement. It's a pretty easy setup, as long as you know how the rotations are working. So again, we're applying the rotation left and right to one object, and then we're using a sub-object for that, for the up and down, and so on. Hopefully you enjoyed this video. If you have any questions or comments, go ahead and leave them down below, and I shall see you next time. Hey guys, thanks for checking out my channel. Misty and I both thank you.
If you enjoyed that video you just watched, make sure you hit that like button and subscribe. Also, if you'd like to support the channel, there's Lame Duck Studios merch. Grab yourself a cool hat, sweater. You can always check out my Patreon, where you can get access to exclusive content just for my patrons, as well as videos ad-free ahead of time. Or pick up one of my books. The Life and Times of Dinah Marton is about a criminal psychologist who moonlights as a serial killer, and The Guardian's Path of Ascension is about 5 teens who realize they have the power of gods and have to save the universe. Both of those are available on Amazon. There are links down in the description. And The Guardians is going to be converted into a comic book. I'm working with my artist Patrick. We're pretty excited. We're shooting for an October release. You can see some of the work that's been done here. And yeah, thank you for watching, and I shall see you next time.